Hi everybody, I assigned for you page 21 of the guided notes, and we're focusing on the percent yield problem. So I assigned numbers 21 through 27, but I told you that I would work through 19 and 20 just in case you needed some extra help with this. I already started number 19. You can see that right there. I needed to write out the equation first. So there's the balanced equation. And we're given 3.74 grams of sodium. So how many moles is that? That's 0.16 moles of sodium. We have excess oxygen, so we don't have to worry about the oxygen at all. We're just going to use up all of the sodium. We'll end up with 0 sodium. How much sodium peroxide can we make? The mole ratio is 2 to 1. All right, so we are simply going to make 0.08 moles of the sodium peroxide. So 0.08 moles. Now we need to see how many grams of sodium peroxide that is. Okay, if we're going to make 0.08 moles of sodium peroxide, that is 6.24 grams of sodium peroxide. Okay, so if we actually made 5.34 grams, which is from the problem, and we had the possibility, the theoretical possibility of making 6.24 grams of sodium peroxide, then what is the percent yield? And we'll find that out right now. And there you have it. So we have a percent yield of 85.6%, and that solves the problem. I'll move on to the next one. Okay, so in this problem, we're reacting potassium and oxygen. This is the balanced chemical equation. But we're given the amount of potassium and oxygen, so we need to find the limiting reactant in order to see how much stuff we can make, how much potassium oxide can we make. So the first step here is going to be to calculate the number of moles of potassium and oxygen. All right, the number of moles of potassium then is 0.18, and the number of moles of oxygen is 0.13. Let's now put together our BCA table. Okay, to start things off, I'm filling in the before part. We've got 0.18 moles of potassium, 0.13 moles of oxygen, and of course, before the reaction starts, we have not made any potassium oxide yet. So which of these is going to be the limiting reactant? Well, let's think about this. If I was to use all 0.13 moles of oxygen, then I would need 4 times this number, right? Here, let's just think through this first. For every one of these oxygens, I need 4 potassiums. So if I'm going to use 0.13 moles of oxygen, I need 4 times 0.13 of the potassium. That's going to roughly give me about 0.5 moles of potassium. I don't have 0.5 moles, so I cannot use all of this oxygen. This is going to be my limiting reactant. The potassium is going to be the limiting reactant right here. So let's do that calculation. So we're going to use all of this. Okay, and if I use 0.18 of the oxygen, 0.18 divided by 4 equals, I'm going to use 0.045 of the oxygen, okay? Again, if you're having trouble seeing this, right? For every 4 of these potassiums, I need only 1 oxygen. For whatever potassium I use, I need 1/4 that number of moles for oxygen. So if I'm going to use 0.18 moles of potassium, I'm going to use 0.18 divided by 4 to get this amount. That's the amount of oxygen that I'll use. And if I run the math on this, that's going to be 0 left over of potassium. And then 0.13 minus 0.045 equals 0.085. This is excess. This is the limiting reactant. Okay, well, how much potassium oxide am I going to make now? Well, we could take a look at the mole ratio, 4:2. So whatever amount of potassium is used, I'm going to make half of that number of moles, because that's a 4:2 ratio. That's 1/2. Okay, so we're going to make 1/2 of 0.18. So let's write that down. So 1/2 of 0.18 is going to be 0.09. I'm going to make 0.09 moles of potassium oxide. All right. How many grams is that? We've got to do that calculation. So let's run that calculation. Okay, so if we made 0.09 moles of potassium oxide, that's going to be 8.5 grams of potassium oxide. How does that compare to what was actually made? All right, let's take a look. All right, 7.36 grams was actually produced. 7.36 grams. All right, we'll divide that by the theoretical amount times 100. 7.36 divided by 8.5 equals, all right, 86.6. Let's make that a little nicer. 86.6% yield. All right, that is our answer. I think you've seen enough of me doing these problems. If I could just give you one last piece of advice, always write down the units that you're working with. Make sure that you know what the numbers mean. Label your quantities with the substance that you're working with. Okay, you'll notice that I wrote everything out here. I didn't do it just for you. I also did it for me to make sure that I knew what I was doing and I was doing the right thing. So I'm going to leave that up to you now. You guys can finish the rest for homework, and I'll see you in class.